Hi, in this video I will be explaining the solutions for the NUFYPET Maths official specimen 2021, questions 21 to 25. In question 21, we are given the diagram with three similar right-angled triangles. We need to find the area of the largest triangle in square centimeters. Clearly, we've got three right angles, and the triangles are similar, which means that we can use the proportion rule in order to find the sides and eventually the area of the largest triangle. I know the two shorter sides of the bottom triangle, so I can find first of all the first hypotenuse. Let's mark it as A. Once I find A, I will use the proportion rule in order to find the side B. Once I know the two sides A and B of the second triangle, I can find its hypotenuse C. And then again, using the proportion rule, I'm going to find the shorter side of the largest triangle, let's say it's D. And then finally, I will calculate the area of the triangle. So step number 1, A equals square root of 3 squared plus 1 squared. That, of course, is root 10. Now, for convenience, I'm going to number the triangles. Let the smallest triangle be triangle 1, the middle triangle 2, and the large triangle is number 3. We can then use the rule of proportionality because the triangles are similar. So in the triangle 1, the ratio of the two sides 3 and 1 is equivalent to the ratio of the similar sides A to B in the triangle 2. And we know that A is equal to root 10. So it follows then that B equals root 10 over 3. Now from the second triangle, we are ready to calculate the hypotenuse C. That's the same as root B squared plus A squared. And this is equal to 10 over 9 plus 10, which gives me a root of 100 over 9, or 10/3. And again, using these similar triangles 2 and 3, we're going to produce the ratio A over B, which is equivalent to the ratio of C over D. Let's express the side D. D equals BC over A. B we found root 10 over 3. C we've just found in part 3, that was 10 over 3 divided by A, which we know was root 10. So now we can get rid of the root 10 and root 10, which is 10 over 9. And finally, step 5, the area of the large triangle equals half times CD, and this is equal to half times 10 over 3 times 10 over 9. So we can cancel out 2 with one of the 2's in the numerator, and the answer is therefore 50 over 27, which in our question corresponds to B. Let's now proceed to question 22. The nth term of the sequence is given by n over n plus 1. We need to find an expression for the difference between the n plus first term and the nth term. To form the n plus first or the n plus 1th term, we are going to substitute n plus 1 instead of n in the original formula. So that would give us n plus 1 over n plus 1 plus 1, which is n plus 2. And we are going to subtract the nth term, n over n plus 1. Let's now simplify this expression. This is equal to n squared plus 2n plus 1 minus n squared minus 2n over n plus 1 times n plus 2. So I'm not going to multiply the brackets through in the denominator. because this is what we have in the given options. But of course we can simplify the numerator. We are going to cancel out some terms, and the result is 1 over n plus 1 times n plus 2, which corresponds to the option B. Question number 23. Given that c and d are non-zero integers, when is the given expression an integer? I just want to remind you that an integer means a whole number without a decimal point. We could solve this problem by factorizing each expression in the numerator and the denominator. So 10 is the product of 2 and 5. That will be 2 times 5 to the power c minus 2d, times 20 is the product of 2 squared and 5 to the power 2c plus d. All of that now is divided by 8 to the power of c, which is 2 to the power 3c, and 125 is 5 to the power 3 times c plus d. Now what I've done here, I have highlighted the like terms. These are the terms that have the same base. Remember, when we multiply the two numbers with the same base, we have to add their indices. And if we divide two numbers with the same base, we will have to subtract their indices. Then for 2, I would have 2 to the power c minus 2d plus 4c plus 2d, that's for the numerator, and I have to subtract 3c from the denominator. That's what we've got for 2. And for 5, we then have c minus 2d plus 2c plus d minus 3c minus 3d, which came from the denominator. Let's simplify now the indices. For 2, we have c plus 4c, 5c minus 3c, that's 2 to the power 2c, minus 2d, and 2d will be cancelled out. And for 5, we have c plus 2c, which is 3c minus 3c, so that's gone. And minus 2d plus d is minus d, minus 3d is minus 4d. So let's now think about the possible values of c and d. First of all, we know that they are non-zero integers, which means they can be numbers such as minus 2, minus 1, 1, 2, 3, and so on. Now, when does this expression become an integer? It becomes an integer if both 2c and minus 4d are positive numbers. Otherwise, if, for example, c is a negative number, then we would have 1 divided by 2 to the power something, right? And this is not an integer. It will become a fraction. So we write c must be greater than 0. We can't have a negative c. And we have the same condition for the index minus 4d. 5 to the power of minus 4d will be an integer if minus 4d is positive. And this is possible when d is a negative integer. So d must be less than 0. And therefore this corresponds to the option E. Question 24. For what values of the non-zero real number a does the given quadratic equation have real distinct roots? Here you must recall the property of the discriminant. A quadratic equation has two real distinct roots if the discriminant is positive. Okay? So the task here is to find the discriminant. Let's rewrite the quadratic equation in the standard form: ax squared plus a minus 2 times x minus 2 equals 0. then the discriminant in this case would be a squared. Let's write it first as a minus 2 squared plus 8a. And this must be greater than 0. Let's now open the brackets. A squared minus 4a plus 4 plus 8a must be greater than 0. This then becomes a squared plus 4a plus 4 is greater than 0. And hopefully you can see that this is a complete square. A plus 2 squared is greater than 0, which is of course true for any a except the one that turns the whole expression into 0. So a must not be equal to negative 2. This corresponds to option D. That was pretty straightforward, wasn't it? Let's move to question 25. A circle has a diameter of 20 centimeters. The line AC is a diameter of the circle. B is a point on the circumference of the circle with AB 12 centimeters. The point D lies on the arc AC on the opposite side to point B. What is the sine of the angle BDC? As with all geometry problems, we will start with drawing a sketch. Let's draw a circle. In this circle, we know that the line AC is the diameter. So I'm going to draw a diameter, something like this, and this is going to be AC. Let's mark the center of the circle, O. So AC is their diameter and it's 20 centimeters. B is a point on the circumference of the circle with AB 12 centimeters. So point B can be anywhere on the circle, let's say there, such that AB, the segment AB, is 12 centimeters. The point D lies on the arc AC on the opposite side to point B. So I can put point D anywhere below the line AC. Let's put it here. I have seen in some other videos that a tutor would put point D over here, directly below point B, such that BD is perpendicular to AC. This is not an entirely correct interpretation of the problem. It is not specified that BD is perpendicular to AC, and the phrase on the opposite side doesn't mean that the point D is the reflection of the point B in the line AC. Okay, so I'm just going to remove this wrong sketch and wrong location of the point D. Potentially it could be there, but it's not specified it's there. So in my opinion, it would be incorrect to represent the problem in that way. Alright, so we need to find the sine of the angle BDC. Okay, so this one here, BDC. The way I suggest to look at this problem is to look at the two angles, angle BAC and the angle BDC. As you can see from the sketch, that these two angles subtend the same arc. I'm going to write it down. Angle BAC and the angle BDC subtend the same arc, BC. Okay, and I meant this arc here, BC. So what does it mean? If you studied geometry well, then you should remember that angle BAC is equal to the angle BDC. So let's assign a Greek letter, let's say theta. The angle BDC is the angle theta, and so is the angle BAD. So I need to find then the sine of the angle theta. Now let's take a look at the triangle AOB. I'm going to connect the points B and O. The first thing we can notice about this triangle that it is isosceles. This means that we have two equal sides, AO and OB. They are both radii, right? And they are equal to 10 centimeters. This also means that the angle A is equal to the angle B in the triangle AOB. So in triangle AOB, AO equals OB equals 10. And also it means that the angle BAO is equal to the angle ABO, and they are both theta. What it means is that the angle BOA of the same triangle equals 180 minus 2 theta. Now I have two angles expressed in terms of theta, and I know all of the sides of the triangle. So I can now use the rule of sines in order to construct a proportion and eventually form an equation in terms of beta. Okay, so let's take a look at the triangle again. The ratio of the side OB to the sine of the angle theta is the same as the ratio of the side AB to the sine of the angle O. So that's AB to the sine of the angle BOA, that's 180 degrees minus 2 theta. Sine 180 minus 2 theta is exactly the same as sine 2 theta. Let's write it down. OB equals 10 over sine theta is the same as AB, which is 12 over sine 2 theta. Now, a bit of trigonometry here. Sine 2 theta is the same as 2 sine theta cos theta. And if we multiply the proportion by sine theta, and also we can divide it by 2, then we get 5 equals 6 over 2 cos theta, which gives us cos theta equals 3 over 5. Remember that we need to find sine theta, so I can use the fundamental trigonometric identity, which tells me that sine theta equals square root 1 minus cos squared theta. Let's plug the number in. 1 minus 9 over 25 gives me square root of 16 over 25, which is 4 over 5. So the answer is 4 over 5, and this corresponds to the option C. So this problem was perhaps one of the trickiest problems in this set, but there's really nothing that you haven't learned in high school. So it's really just a matter of practice. You have to practice as many problems as possible, such that the solution of this kind of problems becomes quick and smooth. Okay, I hope this video was helpful. If you have any comments, questions, or suggestions, please feel free to leave them in the comment section below this video.